We're nearly done with our look at the basics of software engineering and the process of running a program, but there's one last thing I want to briefly cover before we move on, and that's emphasizing the reusability of code. I mentioned this once before, but let's break it down a bit and see why it's essential to our programming careers. When programs become very complex and large scale, writing them from scratch is realistically not very efficient. It's sort of a saying that if an amateur programmer and a professional programmer were given a programming task, the amateur would ask, what's the most original and elegant way to write this code? While the professional would ask, how can I not write this code, and instead use something that's already out there? And obviously, this isn't me giving you the A-OK to start copying code from online, since you have to sort of work your way up to that professional level of thinking, but it's an important idea to keep in mind nonetheless. Reusable code has a couple of sources. Software packages can come with your compiler, or you can purchase them from companies, or you can even download them for free from open source collections. But the reusability of code isn't just using code that's already written, it also means writing your code so that someone else could use it later. It's a two-sided beast. You want to be efficient yourself by reusing code, but you also want to write reusable code so that you or anyone else can use and adapt it later. Writing reusable code has a couple of guidelines. First, your code has to be divided up into small chunks or modules, each of which has its own specific task within the overall goal of your program. For example, if I was designing a program to calculate someone's net income, I could have a module that gets their gross salary information, another module that calculates their tax bracket, another module that applies the appropriate deductions, and maybe another module that determines the final income tax amount. Essentially, you're breaking down your code into independent modules, so it's not just one giant source file, but rather different components interworking with one another. Second, if someone is going to try and use your code later, you have to make sure you've made it well documented so that users know what each component does. You don't need to necessarily explain how a software component does a task, but you do need to explain what it does and how to use it, basically its interface. For example, if someone else wanted to use my deductions module for my income tax calculator program, they wouldn't need to know the exact mathematical calculations behind it, but they would want to know that, say, you need to input the original salary and the sources of deductions. Like, we need to know if our user was putting away money into a retirement fund every month, or if they had insurance premiums, and things like that. Explaining how to use a software component with documentation is essential to ensuring that people can actually use your component in their own projects. Third, components have to be robust, meaning you have to test it under all possible situations and for all possible cases it might experience. If there's any case where your component might not work, you would want your component to handle it properly, like by outputting an error message rather than dramatically crashing without warning. Finally, you want to make it possible to customize and expand upon your components without the other programmer having to completely rewrite them. This could mean if someone wanted to, let's say, adapt my net income calculator program for the UK when my program was originally designed for the US, they'd be able to easily traverse my documentation to figure out what they'd need to modify. And usually, most software components are bundled up with related components and functions into nice packages, which are just useful for other programmers. And again, just to make it clear, the point of this video was not that you should start Googling every single programming project you get out of the spirit of open source code, because then you won't know how to code yourself. The biggest takeaway is that we want to keep in mind that when we write code, it should be easy for someone else to understand it and reuse it in their own projects. This is huge in the professional workplace, and by emphasizing the reusability of code now, we can start to gear up towards more realistic methods of programming.